Alright, so here's the third topic. We're looking at polynomials again, and also we're going to look at factoring for this video. It says here, write a polynomial product which shows the area of the original rectangle before being divided into 4 smaller rectangles and then simplified. Alright, so when you have this and it is looking for the area, you know the area is length times width, so we're going to multiply this side. So this side is going to be, let me write it down for you. It's going to be x plus 2, because we're going to add them together. And then this side is x plus 3, okay? And then, oh, that's a horrible drawing. Anyway, so when you're multiplying, it's x plus 2 times x plus 3, okay? And it's going to be that one. Simplified is we're going to go ahead and actually multiply this out. So to multiply, you can just go ahead and do the first, last, foiling basically. But anyway, this is x times x, which is x squared. And then x times 3, which is 3x. 2 times x, which is 2x. And then 2 times 3, which is 6. And then add these two together, x squared plus 3 plus 2, because they're like terms, 5x plus 6. And that's this part right here. We can always put this part in decimals and check if they're equivalent. Since I did a bunch of that last video, for this one I'll go ahead and just do it by hand, and I know I did this right. It's pretty simple. Okay. Alright, this one says, what is the product of x plus 3 and x plus 4? So product is multiplication, so this is also looks like a little area problem. So the first one I'm going to look for one side is x, which is a big block right here, plus 3, and then x plus 4, let's see, right here, x plus 3 times x plus 4. Think about it as an area, okay? That's it. Which of the following is not a factor of this? Okay, so for this one, I will go ahead and do this in decimals, but first, maybe I'll do it by hand. Yeah, I'll go ahead and do it by hand, but just know that don't freak out if, like after you see it and you're like, what are you doing? But anyway, it says, which of the following is not a factor? First of all, factoring, okay? There's many different ways we factor, but for this one, we'll go ahead and look ahead. Whenever you see 3 numbers, always go ahead and look for the GCF first. So GCF of 4, 20, and 24 is 4. So I'm going to go ahead and factor out the 4 first. So this is 4, oh, let me write it down. Okay, so I'm going to go ahead and factor out the 4. So that's 4 divided by 4 is just 1. 20 divided by 4 is 5x. And then 24 divided by 4 is 6. And then this part, I'm going to go ahead and factor it out. I'll bring down the 4. And this is a simple factoring because there's not a number in front of the x here inside of my parentheses. So you have x, and then you have to look for 2 numbers that multiply together that give you 6, but at the same time, they add up to 5. And those 2 numbers are 2 and 3, because 2 times 3 is 6, and 2 plus 3 is 5. So that's what my factor is going to be. So what does this all mean in relation to what the question is asking? Well, this one has 3 factors. 4 is a factor. X plus 2 is a factor. And x plus 3 is also a factor. So it has 3 factors. So which one is not a factor? 4 is a factor. X plus 2, x plus 3. X plus 6 is not a factor. All that said, let me show you a much easier way to find the factors. Now I'm going to graph it in decimals. So I'm not really changing this to an A because I'm actually wanting to graph this. Think of x factors as x-intercepts. So here 4, there's really nothing I can do. I just know that 4 is a factor because it's the GCF. And then if I plug x plus 3, it shares an x-intercept right there. So I know that it is a factor. But if I put x plus 6 here, it doesn't have the same, why is this so long? It doesn't have the same x-intercept as my graph here, my parabola, which is my original function expression. So that's how I know this is not a factor. All right. This one, it says to factor the expression. So for this one, I do need to look for the GCF. Let's see, GCF of 8 and negative 18, which is 2. So if I factor out the 2 from it, so if I do, oops, sorry, hold on. All right, so 2. So 8 divided by 2 is 4, so 4x squared. And then 18 divided by 2 is 9. And then I notice that these are perfect squares. So this is, you can do a squared minus b squared, which is the difference of cubes. So which would be a plus b, a minus b. So this would be square root of 4 is 2. So 2x, square root of 9 is 3. 2x plus 3. And then 2x minus 3. And it would be this one. You can also compare the two answers by plugging in some number for x, changing it to a, and just confirming that they are equivalent. Okay. Next one, it says simplify using the drop-down menu, write the coefficient. Okay, so basically combining like terms. I'm going to actually make this a little bigger. All right, so here we're trying to combine our like terms. So x goes with x. So 6 plus 1 is 17. X squared, and why is it so small? Hold on. 8, x squared and y, So 8 plus 10 is 18. Negative 7 plus this one, right? Yeah, negative 7 plus 5 is negative 2. And 9 minus 7 is also, well, it's 2, positive 2. And then minus, just be careful here. Maybe I'll go ahead and use decimals for my minuses. So 3 minus 2. Well, that's just 1. Negative 4 minus negative 3. Negative 4 minus negative 3 is negative 1. And then finally, negative 4 minus 3, it's negative 7. Negative 4 minus 3, negative 7. Okay. And that's that. It says here, which polynomial is equivalent? Alright guys, so for this one, I will go ahead and do it in decimals. I don't have the time in this video to go through this by factoring it. Basically, as I'm typing it, I'll explain it. But the way we need to do this is by factoring out the numerator and then canceling it out, and then checking to see, well, which one is equivalent. So, but I'm gonna just do this the shortcut just because it's the SOL, and I'm just gonna check to see which one is equivalent. Okay. There you go, that one. Okay. Yeah, I'll just keep it at like this. We've done factoring a lot in class, so but yeah, that's how I would do this problem since it's asking you for equivalent. So which polynomial is equivalent? So same pattern here, it's just that whenever you see the division, you're just dividing here. I'll show you what I mean. And then divide in Desmos is just gonna put it in the denominator. That's totally fine. And then plug it in, plug some numbers, and then go from there. I'll do this answer choice B. There you go. It's actually answer choice D. Okay. Sorry, I'm not doing it, showing the factoring here, but I have other videos on factoring. You can check them out. All right, identify each expression that is a factor of the polynomial. So I'm going to do this without factoring and show you, like in the first question, how we did it using Desmos, where we thought about factors as x-intercept. But remember that when you have three numbers here, the GCF is also going to be a factor. So for example, 4, -2, and -2. So 2 is a factor. You have to click that one. And then, because it's saying choose all that apply, so we do have to pick each one. That part you're going to have to remember to do. And then the rest of them, I'm just going to check. That is for sure a factor. They have the same x-intercept. And then I'll check the other one. I'm looking for one more factor here. And, oh, well, that works. There you go. If I look at the other two that are not factors, I'll show you why they are not factors. See, they don't have the same x-intercept. And this the other one too. They don't have the same x-intercept. All right. Which expression represents the area of the diagram? Let me go ahead and copy it over to this real quick. So what we really are trying to do here is just count the boxes. So I know that it's going to be x squared right here. And then I have for -1, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have x squared, and then I have -12 little boxes. And then the other one, you see I have these are 3x plus 3x, and then I have 1, 2, 3, 4, -4x here. All I really need to do is put these two together, so that's x squared minus x, 3 minus 4 is -1, so -x minus 12. And that's that right there. So all I really did was just count up the boxes with the key that I have here. Okay? And last one, which binomial is a factor? Well, this is a simple factoring problem. I could definitely do this in Desmos, which I will, but just so you know exactly what we're asked to do here, I'll go ahead and factor this out. This is a simple factor because I do not have a number in front here. If there's a number here, then I'd have to do other things like grouping or the other type of factoring. So anyway, what I'm trying to do here is I'm trying to look for C, the factors of C, meaning two numbers that multiply together that give me 32. At the same time, those two numbers have to add up to -12. So 32, I think 8 times 4, or 4, I don't know. My mind is drawing a blank, so that means I'm gonna just look for them in Desmos. So I'm looking for 32 over x. If I put x and then I go to the table here, that'll give me some factors. And then I'm looking for a difference of -12. Yeah, 8, 9, 10, 11, 12. Yeah, that will work. The 4, 8, and 4 will work. So I can use -8 times -4, because -8 plus -4 is -12. -8 times -4 is +32. So that works out. So the factor is going to be C minus 8 and then C minus 4. So this is a factor. And if I'm trying to put this in Desmos, I can go ahead and look at it. Change that into an x. And then just check x minus 2 is, or sorry, x minus 8 is a factor right there.